Hi everyone, today starts our lesson on probability, fundamental counting principle, and permutations. So let's talk about example 1. TGI Fridays has a deal where you can order an appetizer, entree, and a dessert for a low price. Matilda would like to have every possible meal. If there are 4 appetizers and 3 entrees and 2 different desserts to choose from, how many weeks will it take Matilda to eat every different meal if she goes once a day, every day? So here we are, we have 4 appetizers, 3 entrees, and 2 desserts. We need to know how many different meals that is, so we know how many days and weeks it will take Matilda to actually eat them. So what we can do is, well, we can list them. I have appetizer 1, appetizer 2, appetizer 3, and appetizer 4. Now if I have appetizer 1, I can either have meal 1, meal 2, or meal 3, right? There were 3 entrees to choose from. And if I have appetizer 1 and meal 1, I could either have dessert 1 or dessert 2. If I have A1 and meal 2, I can have dessert 1 and dessert 2. And same thing for meal 3. You have to either choose between dessert 1 or dessert 2. Now it follows that A2, A3, A4, regardless of what appetizer I choose first, I still have 3 entrees and 2 desserts. So let's count how many meals this is. If I choose appetizer 1, meal 1, and dessert 1, 1, 2, so I can have 2 meals if I choose, or I can have, that will give me 2 days if I have appetizer 1 and meal 1, and choose between dessert 2. So that's 2. If I have appetizer 1, meal 2, I have another 2 meals. And same if I have meal 3. So basically, if I choose appetizer 1, 2, 4, 6, I have 6 days worth of meals. Well, same if I choose appetizer 3, appetizer 4, right? Each one of them is going to be set up just like this first one. So that means I have 6, 12, 18, 24 meals. And I want to know how many weeks it will take. So I need to divide this by 7, right? There are 7 days in a week. Well, this gives me 3 weeks and 3 days. Right? If I have 7, 14, 21, plus 3 is 24. So it's going to take Matilda 3 weeks and 3 days to finish each one of these meals. Alright, well, that seemed kind of like a long process, especially if we write out all parts of that factor tree. So let's talk about the fundamental counting principle. If one event can occur m ways, the second event can happen n ways, and the third event can happen p ways, then the number of ways that all events can occur is m times n times p. Now let me talk a little bit about this. What that means is, if we look back at our TGI Fridays example, 4 appetizers, that means event 1 is what appetizers we choose, would be n. So 4, 3 entrees, and if we go to our last event, it can happen 2 different ways, right? We could choose 2 different entrees. Well, that equals 24. That seems quite a bit easier. So let's do a couple examples using the fundamental counting principle. So how many character passwords can be created if the first entry must be a letter and the last entry must be a number? Well, I guess the first thing we have to figure out are the different events that we're having. Well, we're choosing a password. We have letters and numbers. Well, how many ways can choosing a letter occur? Well, there are 26 letters in the alphabet, so it's 26. And if the last entry must be a number, we have 10 possibilities, right? 0 through 9. Those are 10 ways, the 10 ways that event can happen. So our first character must be a letter. So that's 26. Our second character is either going to be a letter or a number, so that's really 36 possibilities. Same with our third and our fourth. And then the only other thing we know is that the last entry must be a number. So that last event in this fundamental counting principle is my last character, which only has 10 possibilities. So all you need to do is type that into your calculator, and you get 121,30560. So 12,130,560 passwords. So this whole lesson is about the fundamental counting principle and permutations. Well, a permutation is this: an ordering of n objects is a permutation of those objects. And in general, the permutations of n distinct objects is n factorial. Alright, so let's go below and talk about a factorial. So we're talking about the number of ways we can order a set of objects. So factorial. So in general, n factorial is n times n minus 1 times n minus 2 times until we get all the way down to 3 times 2 times 1. So for example, 4 factorial is that number 3, that number minus 1 times 2. Oh, you know what? Take it back. That number, n, obviously is 4, times n minus 1. Well, 4 minus 1 is 3. N minus 2. 4 minus 2 is 2. And 1. And that equals a number. 4 times 3 times 2 times 1 is 24. So if there were 4 objects, there would be 24 permutations. So let's use this, just this last example for today's lesson. 8 horses are in a race at the Kentucky Derby. How many different ways can the horses finish the race, assuming there are no ties? Alright, well, we're trying to order these 8 different horses. If we think, alright, how many horses can we choose from to finish first place? Well, there are 8 horses. And how about second place? Well, if one of them finishes in first place, there are 7 left to be ordered into second place. And if we talk about third place, we're down to 6. And now since we have 3 horses in first, second, and third place, fourth place we have 5. And it's going to keep going until we have 1 horse left. Well, we can think back of what a permutation is. It's an ordering of objects. So we have 8 distinct horses. So if I want to know how many ways I can order them, I just need to do 8 factorial. And now you can type in 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 into your calculator, or you can choose 8 factorial, which is fairly easy to do on your calculator. All you have to do is type 8, then you're going to go to math, and then I want you to go all the way over to probability. And if you look down at number 4, we have our little exclamation point, which is what we call a factorial. So you're just going to type in 8 factorial, enter. So now I know there are 40,320 possibilities. So I just need to write equals 40,320. Right? That's how many ways I can order these horses. How many different ways the outcome of this race could be. So then let's think, how many different ways can the horses finish first, second, and third? Well, I kind of touched on this in part A. If I'm just choosing first place, my first place, how many horses do I have to choose from? 8. So now if I move to second place, if 1 horse already finished in first, that gives me 7 horses that can finish in second. Then if I go to third place, I already have 2 horses that are already set and won their medals or whatever. So I have 6 left that could win third place. So in this case, you just need to do 8 times 7 times 6 in your calculator, and you have 336. So it's been awesome talking about the fundamental counting principle with you today and an intro to permutations. Tomorrow we will finish the other side of this note sheet. See you then.